Under the command of Captain Edward J. Smith, Titanic is just past the midpoint of her journey to New York.
The revered and unsinkable ship struck an iceberg and sank 3,800 meters into the depths of the Atlantic Ocean.
The sinking of the Titanic is one of the most famous and tragic stories of all time.
For a century, the Titanic has been hidden in darkness.
Think you know all there is to know about the Titanic? Think again.
It's the Titanic.
"113 years after it sank to the bottom of the Atlantic, it seemed like the Titanic had nothing more to reveal. But in 2025, a surprising discovery stunned researchers. The ship thought to be understood in every detail appeared in a digital model of unprecedented precision, revealing traces that no one had seen in more than a century. Stepping into this layer of data reveals why the 2025 survey is considered a milestone that will change the way we look at Titanic. The 2025 survey marks the first time the Titanic has been fully digitally reconstructed. It is a step forward that reveals the entire structure of the ship in a level of detail unattainable by previous dives, paving the way for a new approach to deep-sea research. To carry out this model, the survey team deployed a network of ROVs that continuously operated around the wreck. Positioning systems kept each device steady in the strong currents and absolute darkness at a depth of 3,800 meters, where every operation required a high level of stability. The multispectral camera system captures the color reflectance and surface condition of each remaining piece of material. The multi-layered data provides a precise view of the current state of the metal, wood, and equipment, even though they have been on the seabed for more than a century in harsh, corrosive conditions. Laser scanners scan the hull with microscopically precise beams of light. Each scan creates thousands of data points, which create a geometric map of the wreck. The millimeter accuracy allows even the smallest deformations to be identified in the steel hull. All data is collected back to the mothership's onboard control system to ensure synchronization. With the combination of multiple scanning angles, previously inaccessible areas are now fully recorded with no dark spots or missed areas as in manual dives. Once all the images were assembled, the engineering team used photogrammetry to create a three-dimensional model. The system compared each pixel, linking the data layers into a seamless structure that covered the entire hull and the debris field that stretched hundreds of meters across the ocean floor. The resulting 3D model can be enlarged to the point where logos on small objects can be read. Individual scratches on the steel walls can be seen, and individual rivets can be identified. The resolution exceeds marine archaeology standards, allowing for a near-perfect reconstruction of the Titanic, allowing for detailed study of each structural element. The surrounding debris field has also been fully reconstructed. Thousands of objects, large and small, scattered on the seabed for more than a century, have been put in their proper places for the first time. The rearrangement creates a complete picture of what was left after the moment the ship broke apart. The model allows experts to rotate angles, change lighting, and observe each area as if they were surveying directly. This eliminates the inherent limitations of diving, where limited visibility and low light conditions affect the accuracy of observation. The ability to simulate stresses from the model helps identify areas of early deformation, areas of high stress, and impact sequences on the hull. This is the first time the Titanic structure has been analyzed digitally instead of relying on inference from discrete observations. Deep-sea engineering units have described the 2025 model as the equivalent of bringing the entire ship back to the surface. The consistency of the images, laser data, and structure makes for a forensically valid replica, reliable enough to reconstruct the sequence of events in the Titanic's final hours. This data set eliminates the need for costly and risky dives. All subsequent analysis can be performed directly on the model, from material assessment to structural evolution studies, opening up new approaches to marine archaeology. the 2025 campaign overcomes the biggest limitation of previous explorations: inadequate coverage. Areas that were in deep shadow or obscured by sediment are now clearly visible, creating the first complete reconstruction since the wreck was discovered. The combination of depth, low light, and extreme pressure had meant the Titanic could only be seen in fragments. The new model removes all these limitations, allowing the entire ship to be seen as a continuous structure, something that had not been achieved in more than a century. From this, new data traces related to the people who stayed on the ship until the last second began to be more clearly identified. Forgotten hero digital images from the 3D model in 2025 show that areas of the Titanic's engine room retain more visible traces than expected. This is a part of the ship that has been little surveyed due to its hidden location and severe deterioration, but the digital model has restored almost the entire structure. In the number 2 boiler area, the steel floor shows signs of inward bending, indicating that water had entered while the mechanics were still holding on to their work positions. This type of deformation only occurs when there is pressure from both the water outside and the strong movement from the equipment inside. Curves in the floor suggest that the boiler system was not completely shut down when the water entered. This means that the fire was maintained long enough to operate the pumps and provide steam to the generators. The residual power provided the final support for the entire ship's systems. The main steam valve system in the 3D model is identified as being open. This is important as this position would not have occurred if the engine room had been vacant. This trace suggests that someone had locked the valve into full operation to maintain power and pressure until the end. Electrical junction boxes located near the engine room showed arc burn marks at multiple points. This type of burn usually occurs when overloaded wiring is manually connected. Matching these marks with the electrical system layout suggests direct human intervention. This reflects the effort to maintain power for as long as possible in conditions of flooding and the risk of explosion. Electricians and mechanics handled wires with their bare hands, in dim light, with rapidly increasing pressure and the noise of operating equipment. Curved steel panels and physical records of the engine room stairwell indicate the presence of a large group of workers at the end of the incident. The steel pieces are tilted in a certain direction, reflecting the people clinging to the structure just before the water was completely gone. Digital model analysis suggests at least 30 to 35 engineers, stokers, and electricians remained in the area. Their presence was crucial in maintaining pressure in the pumping system, keeping the lights on for precious minutes on the upper deck. Keeping the lights on helped maintain order in a chaotic moment. Steady lighting made it easier to launch lifeboats and reduced the likelihood of a stampede. This had a direct impact on the number of survivors. Some early eyewitness accounts mention lights that continued until very late in the day. The 2025 3D model provides physical evidence that matches those descriptions, confirming that the engine room continued to operate even as the Titanic listed and sank more rapidly. The heat from the boiler and the pressure of the water entering the tank left visible deformation marks on the metal supports. These marks only appeared when humans were still operating the equipment, supporting the assessment of the level of determination the crew maintained in the close situation. The data shows that their choice to stay behind was not an act of surprise, but a disciplined decision consistent with their duty to maintain power to the ship. This shows their vital role in the final stages, where every minute mattered to those on the upper deck. Remains of tools, thick leather pieces from work gloves, and torn remnants of insulation indicate continued activity even as the water level rose. These details confirm that they did not leave their positions until it was no longer possible. Evidence from the 3D model provides a complete picture of their sacrifice. This group contributed to the ship's survival, but has long been overlooked or under-referenced in depictions of the Titanic, leaving their true role obscured. The details in the engine room are just the beginning, as new data reveals the full extent of the structural evolution as Titanic broke apart during the night of its sinking. The real tragedy of the tragedy. The 2025 digital model provides the most detailed view of how Titanic broke apart on the night of its sinking. The 3D images show structural traces stretching from bow to stern, reflecting a long chain of damage rather than the sudden breakup previously described. The thin tiers that appeared around the bow area indicate that the initial impact of the ice created very small cracks, only a few millimeters. When they stretched continuously for nearly 90 meters, they were enough to flood multiple compartments at once and put great pressure on the entire structure. The 3D data recorded bends in the keel at multiple locations. These deformations were the result of the bow sinking faster, pulling the hull in a certain direction. As the volume of water increased in the ship, the misalignment between compartments put the structure under increasing stress. Slight twists in the steel frames indicate asymmetrical displacement of loads. This is an indication that the Titanic was not sinking along its axis, but was listing to one side. This deflection created torsional stresses, which directly affected the joints between the hull and the keel. The digital model allows us to see that the fracture process does not occur in a single moment, but over several stages. The cracks appear from the midship area, spreading in a spiral pattern, demonstrating the gradual failure of the structural system as the weight exceeds the load capacity. The stern began to lift as the bow sank, creating a large heel. As the heel exceeded the limit, the stern was subjected to strong pulls that caused the steel plates to bend in the opposite direction. These marks are clearly visible on the model, matching the development of the gravitational imbalance. Separation occurs when the keel can no longer withstand the combined torsional and tensile forces. 3D data shows that the main fracture area is not a straight line, but a multi-layer fracture band. The plates are peeled longitudinally and torn unevenly, reflecting a prolonged fracture process. The tail section rotated almost 180 degrees before hitting the seabed. The model recorded this rotation through the deflection of the steel sections, the direction of fall, and the scattering of the debris. This is evidence that the tail section did not fall straight down, but rotated sharply due to the final drag. The debris field, approximately 600 meters wide, is clearly defined in the 2025 model. Each large and small object has its position and direction of fall, allowing the sequence of breakup stages to be determined. The material distribution reflects the degree of separation of each component during the complete sinking of the ship. The steel plates around the fracture site showed signs of tension before separation. This is the type of deformation that occurs when force is applied to the final load-bearing member. Identifying the areas of steel thinning allows for an accurate reconstruction of the point at which the structure first lost its load-bearing capacity. The model analysis also demonstrated that the notion of a break in two in a second did not fit the data. Instead, Titanic fractured in a series of steps, each leaving a distinct footprint. This sequence of footprints created the image of a prolonged high-pressure breakup. The data also shows a clear difference between the bow and stern after the sinking. The bow sank, quickly falling straight to the bottom and remaining relatively intact. In contrast, the stern was more torn apart due to the greater torsional forces in the final stages, causing it to disperse more when it hit the bottom. The midship section was much more severely damaged than previously thought. Pieces of steel were deformed in multiple directions, reflecting the combined effects of torsional tensile and water pressure. This was evidence that the Titanic did not simply break in two, but was peeled away layer by layer as it sank. Modeling the entire process allowed for a detailed breakdown sequence: early deformation, hull torsion, multiple bond fractures, final separation, and fragment dispersal. This sequence of events was demonstrated for the first time using data, rather than relying solely on eyewitness accounts. But even with the rupture mechanism reconstructed, many areas of the ship remain unexplained. The remaining mysteries. The 2025 digital model highlights many important clues, but also reveals unexplained gaps. Some areas of the Titanic are missing from the rendering, even though ROVs scanned the entire debris field with near-perfect coverage. The midship section, measuring 100 to 150 meters in length, is almost completely missing from the model. This is the area believed to have experienced the greatest torsional forces as the ship broke apart. The lack of intact structures has led experts to hypothesize that the extent of the disintegration is far greater than previously thought. Thick layers of sediment covering the seafloor may have buried much of the detail. Over more than a century, sediment has accumulated, burying many pieces of the structure. Laser scans cannot penetrate this layer, leading to data gaps at some key locations. Some experts believe that the water pressure at a depth of 3,800 meters may have completely broken the steel plates in the midship area. When parts are severely twisted, the fragile structure is prone to breaking into very small pieces, causing them to scatter and be difficult to identify in modern models. The 3D data also revealed that many artifacts were scattered in locations where their original owners could not be identified. The dispersion was so widespread that the connection between the artifacts and their original location on the ship was lost, creating a large gap in the reconstruction of the story of each compartment. Some personal items turned up at depths different from surrounding areas, suggesting that deep-sea currents may have moved many objects over long periods of time. Small movements repeated over decades complicate tracing their origin. Model analysis shows that the Marconi radio room retains many important traces. The scorched and distorted cables suggest high-power operation until the end, consistent with the idea that Phillips and Bride were transmitting at the point where they could no longer continue. Parallel scratches on the transmitter surface indicate strong vibrations during the ship's listing. These marks only appeared when the system was still operating, reflecting the radio crew's persistence in the final minutes, even when the ship's condition was beyond saving. A safe near the officers' quarters was found to still contain a damp piece of paper with clear pen marks. Scans showed the writing was blurred, but the basic content was still recognizable. This is one of the rare details that captures the final moments in written form. The note was identified as a brief note describing the lights remaining on and the loss of the bow. The inscription shows that the writer remained in the same position, reflecting the discipline of the last crew members. This is a rare personal testimony in the entire model. Several other areas of the ship remain unexamined. Many of the metal pieces are twisted in opposite directions, making it difficult to determine the forces at play. This suggests that the structure was subjected to multiple forces at once, creating inconsistent deformation patterns. Several small structural fragments in the middeck area were found as thin steel plates, no longer retaining their original shape. This type of decay may have been confined to areas directly exposed to both torsional and tensile forces, making this area more fragile than other areas. The upper deck frame shows signs of being forced downwards from above. This is the type of deformation that occurs when the stern rotates sharply before falling to the bottom. Determining the direction of fall based on this pressure mark allows a clearer reconstruction of the hull position during the final stages of the sinking. The absence of large intermediate components makes it difficult to trace the chain of events. Although the 2025 model is extremely accurate, there are still areas of missing data due to sedimentation erosion and the effects of centuries of flow. The researchers assess that the 2025 model is not the end point, but opens a new survey phase lasting 10 to 15 years. Deeper scanning methods and seafloor stratigraphy will continue to be deployed to find the missing pieces. The model has brought the Titanic's greatest mysteries into clearer view, but has also revealed more details to unravel. Each new piece of data adds to the final picture of the ship, even though the exploration will continue for many years to come. The Titanic's journey enters a new phase as the 2025 digital model reveals 4 key findings: comprehensive reconstruction technology evidence of the crew's sacrifice, the ship's complex breakup mechanism, and unsolved mysteries. Each layer of data reveals a part of the story that has been invisible for more than a century. If you want to follow the latest updates about Titanic and other historical wrecks, subscribe to the channel and turn on the notification bell so you don't miss the latest discoveries.